Hi guys, today I will explain periodic boundary condition. As you can see from the title of the video that today we will discuss about periodic boundary condition, and it's not a tutorial. It's a concept in molecular simulation that I think is very important, and that's why I'm making a separate video for it. So today I will explain why periodic boundary conditions lead to the idea of infinite replicates and why this become a serious problem for long-range interactions. And in molecular simulation, we cannot simulate an infinite material directly. Instead, we simulate a small box and use periodic boundary condition to mimic the bulk behavior. And this works very well, but it introduces a hidden challenge when interactions extend over long distance. And this, I think I should make it, yeah, so that you can see it clearly. Uh, you can see here in the diagram that we have simulation box, and in reality, we have trillions of atoms for the real system, and we cannot simulate that. Like simulation environment is limited to number of atoms, like maybe maximum we can have billions of atoms inside the simulation system, but not more than that. But in reality we have 10 raised to power 23 almost atoms. So the simulation cell is replicated infinitely in all special directions, and atoms leaving one side of the box re-enter from the opposite side, and periodic boundary condition reduce artificial surface effect and edge artifact. What you will learn after this, one thing, the concept of boundary condition and the purpose of it. Now, the concept is developed to mimic the bulk behavior. Instead, we simulate a small box because in reality we have infinite material. And the purpose is to also discuss the problems you face during periodic boundary conditions. So why periodic boundary conditions are needed? Finite system without periodic boundary conditions suffer from strong surface effect. Atoms at boundaries experience unphysical forces. Periodic boundary conditions ensure every atom experiences a similar local environment and essential for solid, liquids, polymer chemistry simulation. How it is essential for these, we will discuss it in upcoming tutorials. But here I will just want to show you that we can see here unit cell and the unit cell images. So for each unit cell, we have images on the right, left, front, back, up, down, behind. So you see, for one unit cell, we have so many images. So periodic boundary conditions mean that the simulation box is replicated infinitely in all direction. When a particle leaves one side of the box, it re-enters from the opposite side. You see from here? The key point is that there are no surfaces. Each particle always sees neighbors around it, just like a real bulk material. You see, neighbor, this cell is considering these. And however, this also means every particle has infinitely many periodic images. You see, this cell is having the periodic images of itself and other particles. So talking about these replicates, like because this box is replicated infinitely, each particles interact not only um, with particles in the main box, but also with the particles in the periodic images. So it is interacting with the periodic images. This immediately lead to an important consequence the number of interaction partners is infinite, and this is not a numerical artifact. It's a direct physical consequences of using periodic boundary condition. So I will make it clear in a way that the simulation box is running by periodic replicates by itself, and only the central box is simulated explicitly. Interactions are computed using the minimum image convention, and each atom interacts only with the nearest image of other atom. From this, you see that when we have replicates, when we have interactions, so there are possibility of two kinds of interaction, because we don't know for what's the range of that particle, for how long it can interact. So there are short range interactions and long range interactions. For the short range, the rapid decay with there's a rapid decay with distance, like it is uh, directly proportional to 1 over r power 6. So it is very small distance. That's why it involves linear Jones potential and van der Waals forces. If you see the plot of linear Jones potential, that after some time there is linearity, and that's why we specify a cutoff distance. So the cutoff distance is sufficient, and distant images we can get negligible. But for long range interactions that we also called Coulomb's interactions, there is a slow decay because it is directly proportional to 1 over r. So infinite images contribute significantly, and direct summation does not converge. So for short range interactions, we can just give cutoff distance, that till this distance we will calculate it. But for long range interactions, the direct summation does not converge. So this problem is solved by evolve based methods, that is evolve based summation method. So when interactions comes under the periodic boundary condition, electrostatic interactions decay and cannot be truncated safely. Simple cutoff lead to incorrect energies and forces, because for long range we might not specify the correct cutoff. So evolve-based methods are used to handle long-range electrostatics, and common methods are evolve, particle mesh, evolve, and ppm. Simulation cell must be charge neutral. We'll consider this. Advantages, limitation, and key takeaway. So, what we have learned. If you start the video again, you will see that I started with mimicking the bulk material. So what is periodic boundary condition? It's a simulation box in a boundary that is we are studying, and that mimics the bulk behavior and removes the surface effects. But it has limitation, that it has limitation of finite side effects still exist, that's why we solve this problem with understanding the long range and short range interaction. And box size must be chosen carefully and tested for convergence. And for long range interaction, like electrostatic special methods are used, and correct treatment of these effects is crucial for physically meaningfully and simulation correct results. So you understand that why periodic boundary condition is needed. That's the wholesome idea of this video. That in reality, we have infinite number of atoms. Not infinite, but very, very huge amount that we cannot simulate. So we develop a periodic boundary condition, and it comes with understanding short range interactions that are linear terms, like involves van der Waals, and long range interaction, the Coulomb interactions. So how we will incorporate this in our simulation, I will discuss in the tutorials later on. So till now, I think it's enough. Allah Mubarak. Bye.